Hi, my name is Priyanka Vedula, and this is my final project for pattern recognition, face recognition using backpropagation neural networks. A little about it. There is a driving need for enhancing security in various sectors using biometrics unique to a person. Many biometric scans are either expensive or too inconvenient to use frequently. Facial recognition technique is user-friendly and does not require excessive hardware. It involves detecting uniqueness and patterns formed by facial features which are unique for each individual. Major applications include personal electronics, smart cards, law enforcement, surveillance, etc. Humans have the ability to recognize a face without any background condition, even after years of not seeing the face. Therefore, it is the motivation to mimic such a system. However, it is a very challenging task since the human brain is a highly complex structure. Numerous studies exploiting various concepts and problems in the face recognition process have been done in the past. Artificial neural networks have been researched heavily in the recent past because of its similarities to the human brain. Facial recognition algorithm compares a captured image against a database of stored faces and tries to match them. Background, illumination, angle, and other factors make it difficult to do so. Clever techniques are needed to filter out any unwanted information and even out the image under test and stored image. Systems must be designed to accurately classify images subject to a variety of unpredictable conditions. Facial recognition can be divided into two types, feature-based or image-based. In feature-based, it can be further classified into three types, low-level analysis, feature analysis, or active shaped models. In image-based, it can also be classified into three types, linear subspace methods, neural methods, and statistical approaches. These people had a very great contribution towards image processing and thus pattern recognition. Face recognition consists of two major tasks, locating a face from an image and recognizing that face, determining parameters of the image like color, stillness, etc., and checking lighting conditions and filter it out. In recognizing the face, we have to ensure proper capture of the image and filtering the background. We have to match the features with the database. A little bit about neural networks. They're inspired by biological network of neurons. The system trains itself initially and keeps learning with time and use. Each neuron processes data individually and drives the output. The layers of neurons form the entire system. It adjusts weights in training period and learns. It possesses incredible ability to recognize patterns from unknown images. Backpropagation neural networks trains the network to compute a reasonable output for any input that is similar but not the same as the ones used in training. It involves the following steps. Number 1, being feed forward of the input training pattern. Number 2, being backpropagation of the error. And the third one being the weighted adjustment. Now let's look at the implementation of the MATLAB code. For each sub-window, extract the features, then normalize the feature values between 0 to 1, then assign the feature values to the input neurons, initialize the weights randomly between minus 0.3 to 0.3, then calculate the outputs from the hidden layers and the output neurons, then calculate delta and update the weights. This process is done again and again until the target output is equal to the desired output. We will look at the MATLAB code in a short time. Let's look at the comparison between PCA and PCA plus backpropagation neural network facial recognition. PCA plus backpropagation neural network facial detection is quicker as well as comparable in performance with PCA. It gets better with increase in the number of images. The trade-off between performance and response time is acceptable since databases are usually very large. As you can see, there is a trade-off, but as we said that it is acceptable since the databases are usually very large. So these graphs show the recognition percentage versus the number of subjects and the recognition time versus the number of neurons. Now let's look at the MATLAB code. This is the MATLAB code and this is the main function. As you can see, we're going to have two databases, the train database and we're going to have a test database. So these are the images which we have in the train database and these are the images which we have in the test database. We're going to take these two databases and then we are going to start with the training database and then we're going to normalize it. After normalizing it, we are going to find the hidden layers and then calculate the number of iterations to find the goal error. After finding the goal error, we're going to output the number of iterations and the MSE. After that, we are going to recognize the rate. So after that, we're going to print out the recognition rate. Recognition rate is how similar the recognized image is to the original image. And we're going to display the image itself. Now let's try it out. Let's select the train database. As you can see, we can see the iterations and the MSE. Now let's go for the test database. Let's check for the number 1. There we go. Here it will show us the recognition rate, which is 100%, and that it is successful. And these are the images. This was the image which was to be tested, and this was the equivalent image. As you can see, it's the same person. Same person with different expressions. Now let's look at the graph. This was the graph that we had obtained, which we showed in the PPT. Now we can draw a conclusion on the same. The proposed system is both simple and effective and improves the speed of the response. The resulting system can be used to identify phases in many situations. Results confirm the successful operation of eigenphase algorithm in tandem with BPNN. Orientation of phase has some rigidity for detection, which can be solved by further enhancement using ANN. It can be used in biometric related application with large databases. Thank you.